So far, we've been looking at the unit circle as our definition of trigonometric functions. However, there's a way to think about trigonometry using right triangles. The two end up being related to each other, but we'll hold off on making those connections for a little while and just focus on the triangles for a bit. If you have a right triangle, the two sides that make the right angle are called the legs, and the long side is called the hypotenuse. If we label one of the non-right angles as theta, then we can also name the legs by their relationship to theta. One leg is adjacent to the angle, and the other leg is opposite from the angle. Notice that this is labeled relative to the location of the angle, so that if we look at the other angle, the names will switch. The Pythagorean theorem gives us a mathematical relationship between the sides of right triangles. If a and b are the lengths of the legs, and c is the length of the hypotenuse, then a squared plus b squared equals c squared. This formula allows us to find the length of the third side of the triangle if we know just two of them. All six trigonometric functions can be defined in terms of these relationships. A mnemonic device that is often used to remember these relationships is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Those three functions will be the primary functions that we will be working with. The other three are merely the reciprocals of these. The cosecant function is the reciprocal of the sine function, the secant function is the reciprocal of the cosine function, and the cotangent function is the reciprocal of the tangent function. These reciprocal relationships will come up when we're working with analytic trigonometry as well. Once you have these formulas, you can be given a triangle with only two sides known and can compute all six trigonometric functions relative to the angles. For example, consider this triangle. We will label the unknown side a, and then using the Pythagorean theorem, we can determine that a is equal to the square root of 40, or 2 square root 10. Relative to the angle theta, this side is the opposite side, and this side is the adjacent side. And now we just match up the picture with the definitions. It is always important to be thinking in terms of the location of the side relative to the angle. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and the values of cosecant, secant, and cotangent are just the reciprocals of these. Basically, all the calculations will be of this form. It doesn't matter what the numbers are, and there can even be problems where you have variables in the triangle. The most important thing to remember is that the functions establish relationships between the sides of right triangles. In the next video, we will look at special right triangles that give us the values that we used in the unit circle.